Okay, so now we're going to do the item frequency plot, and I know what I'm looking at, so I won't get confused. And let's just read it to make sure. Yep, where item frequency is at least 20%. So this gives us some idea about the support levels. And note, these are only for these combinations, these categories, where they occur at least 20% of the time. So 0 really starts at 20. And again, capital loss, none, is almost complete. And so now we're going to finally create the rules. And let's read what he says to make sure I don't skip anything. So, going to get the rules. The antecedents are going to be either single items or groups of items. Oh, okay. Here we do something new. We're going to use the arguments max length and min length, which control the range of the sum of the antecedent and consequent sets. So what this means is that you must have at least one antecedent, and what 10 means is that a rule cannot have more than 10 antecedents added to the consequent. 9 antecedents and 1 consequent. And so in order to do this, so it's creating rules that contain a wide number, can possibly contain a wide number of antecedents. That is very computationally expensive. So to try and offset that a little bit, we're going to look for sets where the support for the combination of items is at least 0.01, and for rules that have a confidence of at least 60%. So let's do that. So we'll do that. And we want to have the console viewable so we can see what it actually does. It does some computations and takes this pretty fast. So we end up with this many rules, 276,000 rules from an original data set of only 48,000. And the reason there's so many rules is because we put such a wide range between the minimum and maximum length. So we have more rules than we have items. And we can confirm that, how many rules. And then again, we can look at a summary of the rules. And we see the same information before. This, however, summary of rules is not the same thing as the summary of the matrix. These are the number of the combination of the sum of the antecedents and the consequence. And this, actually, I may have misspoken before. What this one, there are 6 rules that have a consequent, but no antecedent. You can generate rules where you have a consequent but no antecedent. Every rule must have at least one consequent. So there are 6 where there's no antecedent and there's one consequent. There are 432 where there's exactly one antecedent and one consequent. There are 4981 that have 2 antecedents and one consequent, and so forth. And then here's the spread for these frequencies. Here's the summary of the quality numbers overall. The maximum lift, 20, that's pretty big. So, and you have maximum confidence of 1, which means that rule always applies. And these, I believe, are just the parameters that we defined. What we did is we mined the rules. And we use these levels for support and confidence in our definition of our original set of rules to create our rules. Okay, so finally now we're going to search over a subset. We want support greater than 0.01 and confidence greater than 60. And we want income small to be on the right-hand side. This operator in R means that it defines membership in the sets. So the right-hand side has a set membership of this. So it'll just generate rules which have income is small on the right-hand side. So let's take a look at that. You got to be really careful not to skip steps, especially in association analysis, because it messes everything up, particularly when you're pre-processing your data sets. It's not harmless. You can't just go back and fill in the missing step because you might have made some sort of unintended transformation which you cannot undo unless you go back to the very beginning. Okay, so we only find 3 rules that have a lift of 1.2 or higher, and note they are all income small, but it gives us some insight into the combination of the antecedent conditions. They all have a confidence of 60% or higher. The antecedent conditions that result in people who don't have money, people who have small incomes. And we could, parse through this. This one's pretty obvious because they work part-time. The hours per week, remember, if it were less than 20, I think it was part-time. So that would be a major explanatory factor in small incomes. Also, this one's part-time. This one's part-time. They appear to be all male. Never married. No capital gain. Okay. So let's do it again, but now we'll go for the high income earners. And note that some of these rules that we just looked at were probably redundant. Let's go for the high income earners. And again, we can define the term for the consequent. But that's really the only different thing here, I believe. So let's do this. So you get a sense in this example that you can tease out a wider diversity, a wider variety of informative, actionable rules beyond simply using it for market basket analysis, where products are bought or occur together. You can create ranges within these numeric variables and define categories like that, such that you can apply this to, numeric issues, but also make any sort of sets of groups as defined by the levels and the factors. It doesn't have to be just tied to things that are bought over a counter. And so here we see with the high income, and note the lift here is much higher. I think we said lift greater than 1.2, just like we did last time. Yep. But we're finding these are the top rules. We're finding much greater lift, and these are the large income, and we see that they all have high capital gains.